Kids are going to be out on winter break, and if they need something fun to do at home, we might have an idea or two for you. Carl Nelson from the Imagination Station is here with a fun science experiment to do at home during the holiday seasons. Good morning to you, Carl. What do you have for us?
I have Oobleck, okay, and this is a really interesting substance.
Okay.
We're going to do a little experiment with it here, and then I'll show you how to make it as well.
All right, now, okay? Oobleck is something you normally don't have at home, but the ingredients you do, right?
The ingredients you do, absolutely.
That's the key.
Cornstarch and water, okay? So
simple enough.
It almost looks like cake batter of sorts. And we're going to do something cool with this because Oobleck is a non-Newtonian liquid.
What does that mean?
Exactly. What does that mean? It means that its viscosity changes, its thickness changes, depending on whether or not you pour it slowly or if you apply a force to it.
Really?
Now, if this was a tray of, I don't know, cake batter, you would probably be hesitant to slap it full force with your hand, right?
I would think so, yeah.
That's exactly what I'm going to have you do.
Okay.
Okay, now hopefully, if what I'm telling you is true here, the Oobleck will thicken up when you hit it, and no splattering action will happen.
I have not tried this beforehand. Whenever Carl comes in, I say, Carl, is there anything I need to know before this experiment? He goes, no, let's just roll with it.
Fine.
So you tell me I have to just whack this.
Whack it. If you go too slowly, your hand will sink in like quicksand, and you may get messy.
Okay.
But just go ahead and give it a good slap.
Okay, set the DVRs. All right, I'm not going to splash you, am I?
I hope not. Now pull your hand out. Get that. You got a little residue because you stopped there, but if you come in and slap it fast,
okay,
you get nothing.
Oh, there's a good example right there.
There's a good example.
I got a good hand. Can I try it again?
Do it.
All righty.
Very nice.
The difference.
So it hardens up when you apply a force to it, right? So let me show you how easy this is to do. If we just take, help me out here, get some cornstarch.
How much? Fill this up here?
Give me 1 cup full of cornstarch.
Okay, I'll do that.
And I'm going to take about ½ a cup of water.
Okay.
We're just going to dump it in, and then the fun part is you just dip your hand in there and start mixing it up.
Right. It's not a science experiment unless you're getting a little messy.
That's right. Now, the neat thing about this, a little more cornstarch.
Okay.
You need a little bit thicker. It's a little too liquidy. Part of this is it's not an exact formula here. Okay. You're just going to sort of experiment with it and try it. Now, the neat thing about this is if you get just the right consistency, you'll be able to get a ball. Chris, I'm going to pass this off to you.
All righty.
You're going to keep rolling it. This is the tricky part. Keep rolling. You got to keep pressure on it. Keep rolling it. Now, just let it stop. Just open your hands up.
No way.
And it
that
starts
was really
flowing like a liquid. It's got a crazy feel when you do that. You can keep it as a ball in between your hands. You can roll it, but if you stop, it'll just start dripping like a liquid. Again,
that is really cool.
Release the force, it flows like a liquid. Add force to it, and it stays hard like a little,
all right.
little ball.
And explain the scientific principle behind this again with the viscosity of it.
So the cornstarch granules, the cornstarch itself, has like sharp little pointy edges, if you will, and the water acts as a lubricant between them. And so the water has what's called surface tension, which keeps it around the little granules. When you apply force to that, you sort of squish the water out, and the cornstarch will stick together. So if you press really hard, it stays like a ball. But if you remove that force, it'll start dripping like a liquid.
Very, very cool.
Now, you can make this at home, but there's another interesting thing you have at home that is almost what I would call the anti-Oobleck.
Okay.
Can you think of something in your cupboard that thickens as it sits and flows when you apply a force to it? Ketchup, perhaps, right? The jar is sitting on the shelf. It'll thicken up over time. It's the opposite. It's a thixotropic liquid. When you start shaking it, adding some force to it, that's when the ketchup starts flowing out.
Very nice.
So it's just like, you call it the anti-Oobleck.
The anti-Oobleck. I love that word.
One very important thing. Do not flush this down the drain.
I could imagine why.
You will have a whole new experiment called Call the Plumber. Okay, because it will harden up. In fact, there was a physics department that was researching this as use for like a top kill for an oil spill. Oh. Right? Normally use that mud they pump down in, but the Oobleck behaves exactly how they want it.
It has now coated my hands here. Yeah, I am Ooblecked out. All right, Carl, thank you so much for your time. Appreciate it coming in with our Oobleck experiment. Very, very interesting. Coming up next, still decorating for